Hello and welcome to the chain rule. This is section 3.4. The chain rule deals with finding the derivative of composite functions. So you're going to need to remember the concept and characteristics of function composition. How to decompose a function is important from one function into two. And you'll need to remember a couple of rules of exponents and logs and Leibniz notation. So remember that a composite function has two parts where you have an inside function and an outside function. So the output from the inside function is the input to the outside function. So we're going to look at, when you look at the derivative of a function, you're looking at how the instantaneous rate of change of the input versus the output. So since we have an extra layer here, we need to consider how the inside function changes and then how that changes the outside function for a change in x. So remember, we really have three variables here. G is a function of x, and we're going to call its output variable u. And then that outside function really is a function of u. And then the final output is the output from capital F, and that's just what we're going to normally call y. So we want to express the derivative of capital F in terms of x. So we don't want u to show up at all. So we want to find the change in g, which is the change in u, for a change of x, which is dx. So if we want to find a rate of how u changes relative to g, that's the du dx. That's our rate. And likewise, a change in u is going to cause a change in our outside function. We're calling that output variable y. So a change in u, which we can call du, is causing a change in y, which we call dy. So we have du dx and dy du, but what we want is dy dx. We want the derivative of this outside function with respect to x. But since a change in x creates a change in our inside function by this amount du, and each of those changes in the inside function results in a change in the outside function dy. So if we multiply these rates, we're going to get the change in the outside function relative to a change in x. And that's what the chain rule is. So dy dx equals dy du times du dx. In other words, for each change in x that affects my inside function u, that's going to cause a change that affects my outside function y. And that's dy dx. So here is the official, statement of the chain rule. And notice there's two different notations given. So there's prime notation with the inside function g and the outside function lowercase f, and then the Leibniz notation. And these aren't really fractions per se, or else we'd be canceling du, but they're limits of fractions. So they're similar, but each of these things on their own can't be canceled like the du's. So let's look at some real composite functions. So let's look at capital F of x equals the square root of 2 minus e to the x. So my outside function is a square root, and my inside function is 2 minus e to the x. So I'm going to say my outside function is f of u equals the square root of u, and my inside function is g of x. It's 2 minus e to the x. So using the chain rule, what I'm going to need to do is find the derivative of the outside function, evaluate it at the inside function, and then find the derivative of the inside function and multiply them. So the derivative of f of u equals square root of u is 1/2 times u to the minus 1/2. So this is the derivative of my outside function, evaluate it at the inside function itself times the derivative of the inside function, which is just minus e to the x. And this is my final derivative. Here's another example of the sine of 3x. So my outside function is the sine of u. My inside function is 3x. So I take the derivative of the outside function, which is cosine u, and the derivative of the inside function is 3. And I form their product, and I evaluate the outside function at the inside function in my final result. So here is f prime of g, and here is g prime. So here's another trig example. So this time the outside function is a power function, u cubed, and my inside function is sine x. So the derivative of my outside function is 3u squared. The derivative of my inside function is cosine x. I form their product, and again I am finding f prime of g of x. So I replace u with the actual expression for g of x in my final result, and then multiply it by g prime of x.